introduce how we can implement the things what we learned so far in the real world. How we can write the program, how we can burn the code into the particular hardware. Usually, in a regular practice, we will do with the real hardware in our lab classes. Due to this lockdown, we are going to miss those sessions. Instead of that, we are going to use some virtual online tool. You may aware of the tool name. It's, right. Ah, so Autodesk. Many of them may aware of the brand name Autodesk. So they have plenty of softwares with them. They are famous for 3D design, CAD design. So you may heard the name called AutoCAD. They have many products with them. Now they introduced a nice tool is called Tinkercad. So now we'll see what is Tinkercad. See, these are all the various products they have. Especially during this lockdown, if you read the slide, they are giving for 100 products available, especially for students and educators and institutions. Out of all the softwares, we are going to use this Tinkercad. So I will tell you how we can get into Tinkercad. So before start doing the experiments, we need to create our own account. Please make a note of this website www.tinkercad.com. It's an online virtual tool. You can have your own account. Whatever the speciality of this is, whatever the thing you are writing in the particular software, it will get stored in your login. So whenever you want to do modifications, whenever you want to add new things, everything will store in the cloud. So you no need to worry about the backup. Okay, clear? Now, what we are going to do today with this account. First, we are going to create the personal account. Then we are going to do the little tasks. So just now, Sir explained how we can blink an LED, onboard LED. So first, we are going to make the onboard LED to blink. And second, in all the cases, the onboard LED is not sufficient. We need to have some external component also. So what we are going to do, once we finish the onboard LED blinking, immediately we are going to connect one external LED, the same pin number 13. Okay, that is the second task. Then we will show you the last experiment, how to make a two LEDs to blink in an alternate fashion. Is it clear? Shall I proceed? So first onboard LED, then external LED, then two LEDs in alternate fashion. Okay. Now, once you get into the website www.tinkercad.com, this is the main page it will get appear. So what we have to do means, very first and foremost thing, this is the, please note down, Tinkercad create 3D digital, like that it will get appear in your window. Then the first step, join now. Is make a note, click join now. It's very simple procedure. I will show you how to do that one. First one is join now. Once you click join now, immediately this window will appear. Here you have three options. One is for educators to start here, then student, then create personal account. So out of all the three ways, we are going to use create personal account. Okay. Once you click create personal account, again the new screen will get appear. Here you have three options. Three options. One is using Gmail, separate account you can create it, or else Gmail or Apple that you have an existing account means you can use the same. So now we are going to use existing Gmail account. I request you all to use our official mail ID in this. So sign in with Google. Then the second screen will appear here. In that you need to select your account. So by default I am having our college ID. If you select your mail ID, immediately you will get this window. Here you need to go through all the terms and conditions. Then you have to click the checkbox. Then click continue. Okay. Sir. Hello.
Gajendran?
Sir, okay then, sir. Visible.
Clear, Gajendran. Clear.
Yes. So what we have done, I will recollect very quickly. Click join, then create personal account, then select any one of the type. Here we are going to select Google account. We are having existing Google account, use the same. No need to do any extra things. Simply select the terms and condition, then click continue. Then immediately the welcome page will appear in your window. So the welcome page, it is a default whatever you saved in Gmail, the same name will get appear. You can view, see immediately once you open the account, there is no circuit available. Immediately they are showing some 3D design. As I told already, they are fully focusing on mechanical component, designing, 3D printing, everything you can do it with this help of the software. But they created one more option for us that is called, as I told you, see here, this is 3D design, it's a default dashboard. The dashboard is the front. So click, well, once it is welcome note, if you click enter, this dashboard will get appear. Here if you see the left hand side, you have 3 options: 3D design, circuits, and code blocks. In that, we need to select circuit. If you click circuit, the window will appear like this. In that, we need to select create new circuit. Please make a note of it. First circuits, then create new circuit. Is it okay? Circuits, then create new circuit. Once you click create new circuit, you will get a new design page. It is like our multi-sim software or Paint, very simple thing, drag and drop, and we have to join the components with the using wires. It is very much similar to your multi-sim software, no need to worry. I will explain you what are the things available in the main window, and immediately we will enter into the real software. Okay, see the top corner, the default name will come. Whatever the project name you like to give, you can give it over there. Okay, then this is our main window. This is like our working space where there we are going to keep our original components, hardware components. So this is our working space. From where we can fetch the component. See, just to right side, you have a component window. From that window, you can select the components. Say example, in this monitor, you are seeing resistor and LED, push button and potentiometer. We need to click any one component and drag and drop it in the workspace. Okay. Then we need to make the connections. And here we are not going to use only the discrete components. We are going to use the microcontroller. So once you made the hardware connection, obviously we need to write the code. So using this option, if you click, the code window will get appear. There we can start type the program. Once you type the program, immediately if you click start simulation, the simulation will get begin. So it is very simple. First we need to open this page, rename it, drag the components and place it in your workplace, then make the connection, then type the code, then start do the simulation. Okay, that's all. Now, so this is our first exercise. Can you see? And there are 4 LEDs available in our Arduino board, as I told already. The L is an onboard LED. Where it is connected, can anyone tell? The onboard LED connected in which port pin? Onboard LED. We have a 0 to 13 digital pins. Can you tell me in which pin it was connected?
13th answer.
13th. Okay, thank you, sir. So this is the onboard LED. Our first task is we are going to make this LED to blink. Now I will show you how to make this with the help of Tinkercad. I think my screen is visible. Just see, just you type tinkercad.com in your web browser and then click enter. Okay, what is the next step? Can anyone tell? What is the next step? Please unmute anyone and tell what I have to do now.
Join now, sir.
Join. Then the next step, I have 3 options. Which one I can select? I can select any one, but we are going to use create personal account. So in that I am going to select my Google account. Actually by default I logged in already, so it is going direct straight away there. It won't show the okay, it is going to come. So I am selecting my personal account. If you are doing it first time, you need to give password and everything. So already I signed in this desktop, so immediately I am getting into this. Okay, so the first and foremost thing what you are seeing is the 3D design. Where we are going to do our experiment with the 3D design or circuits or code blocks. Which one I need to select? Please help me to get.
Many of them have said circuits.
Yes, I'm going to click circuits. So if you get into the system, immediately it will show some sample circuits, and you have a new, if you want to make any new things, you'll get an option called create new circuit. I'm going to click create new circuit. Yes, there you go. So this is our main window. As I told you already, this is the default name. So let me change this as a Lincoln onboard LED. So I renamed my project name, and this is my workspace. Then I have a number of components. See how many components are available. Please see the right hand side. Many of the sensors we are going to deal with. See, if you by default, see this icon components is a drop down box. If you click it, here you have a variety of menus. One is basic, the second one is all. If you select all and view all the components, resistors, capacitor, polarized capacitor, diode, Zener diode, inductor, push button, potentiometer, slide switch, photoresistor. You take all the list of and collect the price list, which will come around 6,000 to 7,000 rupees it may. But in free of cost, we are going to pick all the components and we are going to do the experiment. So I will skip this portion. Check it yourself. See, breadboard is available, Arduino is available, then regulated power supply. What we have used in our lab, regulated power supply. See, regulated power supply, ammeter, many components. See your digital ICs, analog ICs, relay. So these are all the various components available in this particular software. So we are not going to deal with these things. We are going to deal with only Arduino. So I picked a few components and place it over there. How I can remove it? You see here, you have a symbol called delete. If you click delete, the particular component will get disappear. Okay. So again, this multimeter. So with the help of this multimeter, you can measure ampere, current, voltage, and resistance. Okay. In few projects, if you want, you can use this also. I'm going to delete this. Okay, tell me, for our experiment, what component we need to pick? Please help me to choose the component. Or onboard LED blinking. Can anyone tell what I need to pick it from this list? What are the components we need? Hello? Hello?
LED resistor.
No, for onboard LED alone. Simply the microcontroller board alone is sufficient. Okay? See here, Arduino board alone. Okay, see in the right hand side, we are having two microcontrollers are available. In that we are going to use only the Arduino Uno. Just click and drag and drop it in your working place. Okay. So now what we did, so we selected the component. So Arduino board, now we got it. Now just drag your cursor and place it in these connectors. What it shows? Any view D0, D1, D2. So what are the things we have studied so far? Everything is labeled over there. At the same time, whenever you are making the connection, to make you to ensure they are giving some highlighted label. So D0, D1, D2, D3, and so on up to D13. So is it okay? So we are having 14 digital pins. And what else? The nearby 13th pin we have one ground pin. Okay. The next one A reference that we'll see later. So these are all digital input and output pins. Okay. This is your microcontroller Atmega 328. Then this is your analog input pins. How many analog input pins are available? How many analog input pins are available? There are 6 pins. So start from A0 to A5. See here, A0, A1, A2, A3, A4 and A5. These are all analog input pins. Then power pins. In power sector, you have few pins. P-in. P-in is the input pin. So as sir told already, there are 3 ways to power this Arduino board. One is using USB cable. The second one is using this power jack. The third one is using this V-in and ground pin. Together we have to use, because voltage means 2 terminals. The potential difference between 2 terminals. So exact 5 volt we need to apply across these 2 terminals. Okay. Out of all the pins, these 2 pins alone is the input pins. Remaining all pins are output pins. Please make a note of it. If you give power in any one way, that is either using USB cable or using this power jack or V-in and ground. Please, you can observe why I am telling or. At the time, we can power in any one way. If you give everything in a single attack, the board will get burned. Okay, the board will get damaged. So at a time, we have to power your board in any one way. Okay, so the remaining pins, the ground, 5 volt, 3.3, these 3 pins are output pins. These 3 pins are output pins. Then reset and IO reference. Sir, tell me. Hello? Hello? Hello, sir?
ராம் சார் சொன்னாரு, ஆனா வாய்ஸ் கட் ஆயிடுச்சு திருப்பியும்.
So shall I continue, sir?
நீ கண்டினியூ பண்ணுங்க, அவர் தான் சொல்வாரு.
Okay, that's all. So now everything is over. The hardware, see, single day you can't memorize everything. Practice it will come, don't worry. So now we selected the hardware. What is the second part? Can anyone tell? No additional hardware connections we are going to do, only onboard LED. What I have to do next? Can anyone tell? We need to write the program where we can type our code. This is the place where
voice konjam break aagi kekudhu.
Okay. So now is it okay now?
Voice break aagi kekudhu.
Sir, ipa? Hello?
I think ராம் சார் உங்க லொகாலிட்டி நினைக்கிறேன். எனக்கு கிளியரா இருக்கு ராம் சார்.
ராம் சார் கொஞ்சம் செக் பண்ணிக்கோங்க.
லைன் ப்ராபபிலி பர்టిక్యులர் அவர் கனெக்ஷனா இருக்கலாம். எனக்கு வந்து கிளியரா இருக்கு.
Yes, sir. Yes, sir. Okay. So with that short feedback, I am continuing. If you have any audio issue or anything else, please type it in chat box. Therefore, they will interrupt me because I can't view the chat box. Okay. Now we are going to write the program in this code block. So here, if you click code, immediately you will get one window like this. No need to afraid about these icons. We will see this one later. In that you have again three options. Please make a note of it. Blocks, blocks plus text, then text. In this, we are going to select text. I repeat once again. If you click code block, I will show once again. If you click code block, this window will get appear. You need to select text. Okay. If you select text, task shall be continuous. Okay, I'm going to continue. Without typing the program, they are giving the codings. How it is? So by default, I think this program may have been. So let me delete this one. By default, there will be some other program, same LED blinking with different coding. Okay. Yes. Now we are going to start type the program. So there are two functions as we discussed earlier, void setup and void loop. In void setup, what we have to do, can anyone tell? Void setup. So before that, I will tell you one thing. Here, the structure of the Arduino program is called as sketch. Please make a note of it. If you start type the coding in your Arduino IDE, immediately it will tell sketch. By default, it will give the name as sketch. S-K-E-T-C-H. So this is the structure of the Arduino. So the same thing we are going to type it over here. So the void setup, it is like your C program, very simple. In C program, what we will do, the first one is header file, then initialization, then our main program, then number of loop. If you have any sub loops, we will start the program. Likewise, in void setup, what we are going to do as an embedded system engineer, what we are going to do is, what is the hardware we have, we know. What is the output we need to make, we know. Based on these two categories, we need to initialize our program. So in our today's task, we need to make the pin number 13, that is digital pin number 13 as an output pin. The setup, in setup, we are going to initialize only this instruction. Void setup and the pin output configure panna podum. Okay, ba? So output configure panna, I must know what is the syntax for it. Okay, let me open the loop and start type the code. It's very simple. Can anyone assist me? What I have to type to make the pin number 13 as output? Which syntax I need to use? Which syntax?
Harshini has written pin mode 13, output.
Very good, sir. Okay, sir. Pin mode. Pin mode. Please observe the syntax. It is case sensitive. Case sensitive. Here P, I, N, pin. Everything is small. M is caps. Then within the function, I'm going to write the number pin number 13 as output. Is it okay for everyone? Pin mode 13 as output. Then I have to terminate the function using semicolon. So in void setup, step number 1, we configure the particular pin as output. We want to add command lines. As a good programmer, if you write any single line, make some command line, because in future you can refer the coding. The command lines you can understand very easily. How to write the command line? See, simply make 2 backslash and start write the command. So whatever thing I am going to write it after this, it will not consider as a program. It is going to consider as a command line. So what is the command line I can write here? Make pin 13 as output. That's all. So my void setup function is over. And what I have to write? the main function. Here we need to blink our LED. Okay, so the onboard LED is connected in pin number 13. So I'm going to start write the main program in our while loop. So to make the pin to high, what syntax we can use? Can anyone assist me? What syntax I need to type?
Yeah, they have written some
Digital.
right 13 comma high, 13 comma 1.
Yes, sir.
All this have been written.
Yes, sir. Okay. Digital write. Digital write. Here also please observe digital write. So W is capital. Then I need to use the same pin number. What I have used in the void setup, the same pin number I need to write it here. Pin number, comma, high. I need to terminate the program. Then what we have to do? I made the pin to high. Shall I immediately make the pin to low? No, because the microcontroller will process the particular event in a very fast rate. So we can't visualize the on and off action. So I need to include or add some delay function. Okay. So here it is very simple. I'm going to type the inbuilt function delay. Whatever the thing I'm going to type in this particular bracket will be considered as a millisecond. So here I have typed 1000. So what it means? That means I'm going to generate delay for 1 second. What is the previous command? The previous command make pin 13 to high. Okay. So now what we did, we made the pin to logic high, then we introduced one delay. The second task, I need after some time delay, I need to make the same LED to off. So how I can make it into off? Again, the same coding, the reverse logic. Previously it was high, now it is low. Close the bracket and terminate it. Immediately comment the line, make pin 13 to low. Okay. Then if I include only these lines, again I can't visualize the blinking action. I will show you that one. Now I will add you straight away delay. After showing this demo, we will remove this particular line and we will check it. Okay. Again, we are going to create a delay for 1 second. Is it okay for everyone? If you have any doubt, please raise your doubt. Because this is a very, very fundamental thing. Once you understand this, then you can do wonders in this. Do you have a doubt? Please interrupt me. Else I will continue. So I repeat once again. Get into the software, rename it, pick the component, get into the code block, and type your code. We have 3 options. Please choose text option. Is it okay for everyone? Okay. Now I need to simulate. I need to simulate the particular event. How I can simulate? See here, on top of the menu bar, you have a start simulation. Click start simulation. Can you see the output? So here it is not appearance is not good. So what we are going to do? We are going to close the code window. How I can close the code window? Just again click it on code and it disappear. Can you view the output? Can anyone view this one? So what is our aim? Our aim is to blink the LED. See the same thing we got it over here. Okay. Is it okay? Now I will do one thing. How to stop the simulation? See the same icon, the same tab. Once it is in simulation mode, it will show it as a stop simulation. If you click the same button, it will give us a start simulation. The same button for both start and stop. Okay. So I will do one thing in the same program. Sorry, in the same program, I am going to remove this line. What I did here, how to inactivate the particular line, make it as a comment line, because in future we want to use the same line. If you delete the line, again you have to retake it. So better practice, if you want to inactivate the particular line, make it as a comment line. Okay, see here. With this code, we are going to check the simulation. So what I am telling is, we will commit those mistakes I am making here, because we are not inside the lab. So if you are making so much of mistakes, you won't get output, then you lose interest. That's why I'm showing few mistakes, the common mistakes, what you will commit. Okay. Now I'm clicking start simulation, closing the window. Can you tell what is happening over here? Whether LED is getting blinking? Tell me. What output you can observe? Whether LED is getting blinking or it's continuously glowing? Hello? Hello?
கேக்குது சார்.
Yes, sir. Continuously it's glowing. Very good. So what I have to
Glowing.
do? So what mistake we did? See, in this particular code, after making the delay, we are not introduced. See, after making the particular pin into low, we didn't introduce delay. If you make this kind of error, you can't observe the blinking action. So the very simple thing, whenever you want to make the particular event for a particular duration, we need to give particular delay time. So here I am giving delay time as 1 second. Okay, is it okay? So let me stop the simulation and uncomment the particular. So the first task is over. So our next task is observe. We will come back to our PowerPoint presentation. See, this is our second task. Please observe the animation over here. The same pin number, the 13th pin number, we have connected into the external hardware. So Sir explained already how we need to make the hardware connection in that. See, I'm going to connect the external LED through the resistor, current limit resistor, then LED, then the cathode terminal is connected to the ground. So for this experiment, what are the additional hardwares we require? We require breadboard, resistor, LED, and connecting wires. Okay. Come back to the software. Come back to the software. So it is better practice whenever you are making new circuit, go back and create new circuit and come back. Okay. Create new circuit. Don't write all the codes in a single file. In future you won't get it. At last you will have only one project in your hand. Okay, it is best practice. Create a separate files for a separate project. Okay. So now I'm going to rename it as blink and external LED. Okay. Blink and external LED. So as usual, I need to pick the controller, Arduino, then I need breadboard. We will take mini breadboard. Okay, we'll take a small. So, we'll take small. Because this board is universal, can use it for many of the experiments. So let me start with the same. Then what are the components I need to pick? So I placed the Arduino and breadboard. Can anyone help me to pick remaining components? What are the other components I need to pick? Please type it in chat box. Resistor and LED. Very good. Okay. Resistor and LED. See here, LED. Okay. Then resistor. This is the very first element. Pick it. That's all. Then If you want to do the work at the workplace, what you have to do, close the see. If you click this arrow, it will get disappear. If you click it back, it will come. So once you choose component, close it. It is very much comfortable to draw the diagram. Okay. Now I need to arrange the components. Okay. So this is my LED. If you click LED, this particular box will get appear. I think everyone can view this one. Here I can label it. I can give the name for this LED as just LED or else LED 13. Then you know that we have a multi-colors available, not red only. Here in this window it is showing red color, but you have few more options. You can choose any one color for your project. Okay, green, yellow, orange, blue, red and white. So at no cost we are going to choose these LEDs. And now by default I am going to keep it as red color. Okay, then see, if I bring the cursor over here, immediately it will label the terminal. You no need to memorize anything. See, cathode. Then the second terminal, obviously it is anode. So as I told already, with the help of the terminal length, the lead length you can observe, or else please observe this flat edge. So this is flat. Nearby the flat you are having cathode. So let me place the LED into my breadboard. So I hope everyone aware of the breadboard connection. We are not going to teach the breadboard connection. So these are all horizontal lines and vertical. See, just you keep the cursor, it will show the light green line. Where and all you have the connectivity, it will show. If you come down, it will show the second line. For vertical lines also, see, all the 5 dots were connected. Okay, good. Now we place the resistor. What else we need to do? We need to connect the resistor in series with my LED. See, that one more thing. See, if I select the resistor, as usual it shows the labeling name. Then what is the value? By default it is 1 kilo ohm. See, from pico ohm to giga ohm you can select. See how much range they given here. For our experiment, can anyone tell which one I need to select? Whether I need to select giga ohm or mega ohm or kilo ohm or ohm? Please assist me. What I need to select? Just ohm. Very good. Just ohm. So I am selecting ohm. What is the value of the resistor? But also some.
Many of them have type 220, 330.
Very good. I'm going to type 220. 220. Okay. Then one more option. So if I am not comfortable with this position, if you want to rotate the component, how I can achieve it? Very simple. See, select the component, go to this rotate option. See, select the component. If you select the component, it will get highlighted. See, now I have not selected any of the component in this workspace. So if I select the component, immediately this label will get appear. Immediately go to rotate. Rotate option you see. See, if once you click, it will move to 30 degree. Okay. Now 30, 60, 90. Then again 30, 30, 90. 30, 30, 30. Can you see this one? So it is very comfort. So you can move to rotate the component only within this range. Okay. So now I am going to rotate the component to 90 degree. And I am going to bring the. That's all. So what we have done, we made the LED and resistor to connected in series. The anode terminal is connected to one end of the resistor. Another end where we need to connect, can anyone tell me? Another end where I need to connect? As per our circuit diagram, please refer our circuit diagram and tell me. So another end I need to connect to the pin number 13. The last connection is I need to connect the cathode terminal into ground. Okay. Yes. You have to pick the wire. Don't search anywhere. Just click where we need to start the wiring. Just click the terminal and move it. Immediately the wire option will get appear. By default, it's green wire. I will show you how to change the color also. So I need to route the wire in a very clear manner. Don't immediately go and connect it in the required terminal. Okay. You want to drag the wire in a neat way, click. Once you left click in the mouse, it will get a now I need to move the wire here nearby 13. Again I am going to click, left click, then bring the wire. It is not good. I can move it like this. I can do these adjustments. Can view this one. And I'm not happy with this color. What I can do? Shall I change the color? Yes, that option also available here. See, the plenty of options are available. As for our color coding, so we will choose red color. Yes, good. It looks nice. Then what we need to do? We need to connect only one wire from cathode to the ground. Yes. Bring it down. Is it okay? Yes. Change the color as black. That's all. Looks nice. What we will do? So we finished our hardware set. What we need to do? We need to write the coding for the particular hardware to make this particular external LED to blink. We'll try that. Go to code, choose text, continue. Yes. See, this is the default program available in the software. So it is same as our blinking program. Shall I use the same? See, go through the commands. Void setup, pin mode 13 output, then loop the same pin 13 high, delay 1000 and delay 1000. And one more thing I will show you in this point. If you commit any syntax error, that is a common mistake. Now I am going to change this W capital into small letter. Okay. Try to simulate your program. You will see what is going to happen. If you start simulate, see, you will get the error window. The bottom of the code window, you will have the message window. In that it will see, you no need to search where we made the mistake. It will highlight. The software is so intelligent. See, it is giving error in this particular line. Digital write was not declared in this code. Means what? Maybe the syntax is not relevant to the particular program, or it may be the wrong. We may type it like this. So once you change the syntax, then again you start saying, yes, no error. So what we did, once you do say in hardware, what we have to do, you need to first compile, then upload. Here, both two actions are happening in a single step. If you click start simulation, itself it will compile and it will get uploaded. Now you observe the hardware. See my external LED, how nice it is getting pink. Is it okay? Do you have any doubt so far? Please tell me. We have hardly 9 minutes to complete. With this, I need to complete one more experiment also. In the same experiment, I will show one more thing. So now the blinking rate is on time is 1 second, off time is again 1 second. So what we are going to do is only two tasks. To please wait for some time. See, only these two tasks. Immediately we can wind up. So blink an LED in pin number 13 with on delay is 5 seconds, off delay is 2 seconds. Can anyone assist me? What is the modification I need to do with this coding? Assist me. On 5 seconds, off 2 seconds. where I need to do the modification in our program. Please tell me. Delay, very good, very good. So after write, so on delay is 5 seconds. So 5 seconds means 5,000. Off delay 2 seconds. Make it as a 2 seconds. See how simple it is. If you are having discrete components, you have to change all the resistor and capacitor values to change the delay. See, if it is a coding part, how simple we can make the modification. If customer asks the delay, I don't want this one. See, initially they will tell something. At the end of the product, by seeing the actual output, they will ask to modify. If you are having coding part, immediately you can change the code and you can complete your code within the minutes. See, can observe the change in code. Yes, how nice. See, on time is 5 seconds, off time is 2 seconds. So this is the, in this way you can edit your code. Okay, you can edit your code whenever you want. If you want to add any hardware component, immediately you can add. And one more thing you have to notice, if you want to do any modification while the system is in a simulation mode, you can't do anything. Okay, stop the simulation, then do the modification. Okay? I hope this is clear for you.
கஜேந்திரன், ஒரே ஒரு இது மட்டும், இந்த நிஜமா போர்ட்ல பண்றவங்க எந்த ப்ரோக்ராம் மாத்தினாலும் they have to compile and
yes sir. See, I will show you. See, this is our see how, see, this is our Tinker exercise program. See, once you finish your project, it will get appear. You want to again edit, click Tinker this. Click Tinker this. It will come to the original window. There you can edit it. See, click code, copy the code, come to our Arduino IDE, paste the cell. Okay. So here I have a hardware board. I have connector. I will show you. See, once you see, by default it will show the current date, today's date. If you want to modify the date, you can do it. Okay. So here, file, save, do the name as onboard blinking, save. Then please make a note of this one. Whoever having the hardware component, you have to do these 3 things. First, you go to board. Here you have variety of boards in the Arduino. You have plenty of versions available. Day by day, they are introducing new versions. See, so many variety of boards are available. In that, you need to select Arduino Uno. But by default, it will appear only Arduino Uno. The second one is you need to select the code. Why I need to select the code? I am writing the program in my computer, but I have to execute the code in extra hardware unit, additional. So I need to communicate with the help of the COM port, that is your USB port. Many of them are aware of this one. There I need to select the COM port. Once you select the COM port, step number 1, let me maximize this. So maximize all properly. See, now you can see. Go to the first icon. Please observe, whenever I am making the change, please observe this particular area. There you will get some message. Now it is done saving. I hope everyone can view this one. Now I am going to click verify. See, those who are having hardware only it works. See, done compiling means what means the compile action is finished. Now I need to move the particular code into my hardware. Second icon, very simple. See, then sequentially they have kept. First compile, then upload. Upload means what? Write the program into the external hardware. Click upload button and observe the process. Uploading. Done uploading. What it means? Done uploading means the particular code is dumped into our external hardware. Okay. Then if you view your hardware board, you can observe the blinking action as same like our hardware. Those who are having any difficulty with this, please contact us. Okay, this part we will hold it for some time. So is it okay, sir? Shall I proceed the last one, sir?
Yes,
Hello?
Gajendran, probably 5 minutes extra will be there.
The last one I will show you. So it is a very simple
Finish
experiment.
it in 5 minutes, please.
Yes, sir. Let's see, this is the last task. Please make a note. Very simple. I'm going to connect two LEDs in pin number 12, 10 and 12. Okay, 10 and 12. So what I need to make, this is the task. First LED, then second LED. Then immediately, the second LED has to be off, first LED. So alternate fashion, I need to blink like this. Okay. So using same blinking program, it is not possible because here we are going to use two LEDs. We will do all the modifications. Let me use the same board. Okay. Stop simulation. See, if you want to get any fresh component, Control C, Control V. It's a shortcut. See, delete this component. If you want duplicate of the LED, select the component. Control C, Control V. You will get again one more LED. Okay. Then resistor again. Control C, Control V. How easy it is. That's all. Now delete this one. I need to ground this terminal also. Is it possible to connect two wires? Two wires? No. So what I have to do? Come back. If in the breadboard, if you are making common connection, I will show you that immediately. For this problem, what we will do? Take the ground wire. Take the ground wire. Keep it over here. So you know this connection. This is the common ground. So wherever you want, you can tap it from here. So now it is simple. So make it into black. Then you can change the color. I may go little fast, but you can follow it. What are the pin numbers? 10 and 12. 10. First LED I have connected in pin number 10. Red color. The last one. Change the color. Okay, that's all. Hardware connection is over. Come to the code. Tell me what are the modification I have to do. Void setup. Void setup. We need to use pin number 10 and 12. So simply, I'm going to copy this line. Make the duplicate line. First, I'm going to change the pin number alone. Make the pin number 10 and 12 to output. 10. Again, I'm going to see, tell me, whenever the first LED is on condition, the second LED must be off condition. So what I have to do? Very simple. Make the pin number 10 as high. Make the other pin into low. Other pin into low. That's all. Again, pin number 10. Now, in previous case, 10 is high. Now I am making 10 into low. I am making 12 to high. That's all. Let's go through the program. I made 10 and 12 as output. Then I'm going to make first 10th LED as high. At the same time, my 12th LED is low. After some time delay, let me make it as 1 second. Okay. After some time delay, I'm going to toggle the action. That means high to low, low to high. Is it okay? 1 second. Start simulate, that's all. Task over. Can you observe the output? Let me increase little delay. It's 2 seconds. 2 seconds. 2 seconds. That's it. You see the alternate LED blinking. So first pin 10. See now whenever 10 is on, 12 is off. Whenever 12 is on, 10 is off. That's all. So our part is over. You have only one task as an. Please take down the question and observe the animation. This is your only one task for this class you need to do. Here we are going to have 4 LEDs. 4 LEDs. Please observe the animation. Now first LED is, see initially no LED is on. Then once you start run the program, first LED has to glow. After some time delay, first LED has to off and second LED has to turn on. Then after some time, 2 has to off, third on. Then third off, fourth on. And the same setup need to continue. Now fourth has to off, first has to on. Can anyone tell by comparing this animation what structure is C program? If you write the program in a particular structure, you can do this one in a repeated manner. Can anyone tell? You should not use the same type of code what I have used. So as a efficient coder, you try to reduce the number of lines. What type of loop you can use it? For that, I will do.
Yeah, some of them have said looping. Some Janani has said for loop.
Yes, very good.
Lokasega has said for loop.
Yes. For that, I will give you only one small hint. These pin numbers need not to be always an integer, so need not to be the exact pin number. In this particular function, you can declare any one variable. Okay, those things you need to initialize before. I will give you only small hint. I am taking int a. So this particular int a I assigned here. So with this help of this particular int, try to implement the program. If we have any doubt, contact us. How to post means we will send you one Google form. In this Google form, whatever the code you are typing over here, please copy your code and paste it in Notepad or MS Office. Okay, Notepad is best. Open Notepad, paste your code. If you please include some command line also, then only you will come to know why you have written this code. Then very important, please listen. While save the folder, see there are 140 students. You need to process simply means I will give you a simple step. Please use your register number 19L101 underscore. Everyone please follow this step. Your register number followed by DAY-1 task. We are giving multiple tasks. Please add here as task 1 and task 2. Please follow the same way to save your file because it is easiest to access your code. Okay, save it. That's all. Then you attach this file into the Google. And one more thing, in your mobile phone, please take the screenshot of your animation work. If you are having a laptop, you have a variety of softwares. You have a FreeCam software. This is the screen recording software. With the help of this software, you can record your screen. See, this is screen FreeCam. See, with single click, the screen you can start record. So if you record, likewise, you record your particular output, and the size of the file must be less than 100 MB. Okay. Just you show the output of your screen and stop recording and save the file as a MP4 and upload it. Okay, if you find any difficulty with this, see, that's all. I'm going to save the file, save project. I'm going to save project as on board banking. So here also you follow the same thing. 19L 101 day 1 task. Likewise, you save your video also and attach these two to particular Google. I hope it is clear for everyone. See,